Hello. Today we will be talking about memory, not just about how and where memories are formed in the brain, but also about a dissociative disorder which results from the partial loss of memory, known as amnesia, in addition to how exercise, diet, and sleep affect memory. So, sit back, grab some popcorn, and enjoy this video. Now, I bet you're thinking, but how are memories even formed? Well, there are several different types of memories, and each are found in different areas of the brain. I have inserted a picture of the various areas of the brain above so you can see exactly what part I'm referring to. Procedural memories, which store information pertaining to the performance of certain actions, is in the cerebellum, which is located behind the top of the brainstem. Research involving PET scanning techniques has suggested that short-term memories are stored in the prefrontal cortex, which is located at the front of the frontal lobe, and the temporal lobe, which is right in the middle of the brain. If you have short-term memory and cannot remember what PET scanning is from a previous chapter, see what I did there? PET scanning involves a special dye that has radioactive tracers. Interestingly enough, episodic and long-term memories are also stored in the prefrontal cortex and the temporal lobe, though at different locations than the short-term memories. Changes in the number of receptor sites, the sensitivity of the synapse, which is a junction between the axon tip and dendrite through repeated stimulation, and changes in the dendrites, which carry electrical signals into a neuron for the connected cells, are the various physical changes involved in the formation of a memory. Now, I'm going to introduce you to an important process, which you will learn a lot about later in this video, and that is a consolidation process. When a memory is formed, the changes that take place in the structure and functioning of neurons is known as consolidation. The hippocampus is located in the medial temporal lobe of the brain and is responsible for the formation of new, long-term declarative memories. One would be unable to consolidate and store any new factual information they encountered without the hippocampus. Now, it's time to get ready for an engrossing story time. Yay! There was once a name known as H.M., who we now know as Henry Gustave Molaison, who began to suffer from severe epileptic seizures when he was just 16 years old. In an attempt to stop his seizures, a surgeon conducted a procedure in which he removed H.M.'s hippocampi and adjacent medial temporal lobe structure. Without the hippocampus, H.M. was no longer able to remember new events or facts, and consolidation was impossible. The last thing he remembered was being rolled to the operating room. This sounds pretty terrible, huh? Similarly to those with amnesia, H.M.'s procedural memory was intact, though both semantic and episodic declarative memories, which pertains to long-term memories, were completely lost. Oh shoot, I forgot about what I needed to talk about next. It's amnesia!
So today, I'm going to be talking about amnesia. Amnesia is a partial or total loss of memory. There are three types of amnesia that can occur. There are retrograde, anterograde, or infantile amnesia. Retrograde amnesia is the loss of memory from a point of injury backwards. In this situation, the hippocampus, where memories are stored or made, gets temporarily disconnected, so some memories are lost. In anterograde, on the other hand, the loss of memories occur from a point of injury forward. In this situation, the consolidation process, which is a process in which the brain is making physical changes for new memories to be stored, is disrupted. During injury, this memory is disrupted and memory making is not finished. Both of these can be seen in Alzheimer's disease, in which people have trouble making new memories and can't remember their past life memories. And lastly, infantile amnesia happens in kids before the age of 3, usually, in which early memories are implicit, which basically means difficult to bring to consciousness. The memories are made, but they're hard for the brain to bring back.
Sleep, diets, and exercise are imperative for forming new memories. Starting with exercise, researchers had people 50 to 85 years old look at pleasant images of nature and animals. After viewing the pictures, half of the participants rode on a stationary bike for about 6 minutes long. An hour later, they were given a surprise recall test of the previously viewed pictures. The participants that had exercised showed an improvement in memory when compared to those who did not exercise. When you exercise, norepinephrine, a neurotransmitter found in the brain, plays a strong role in the forming of new memories. This may be an explanation for improved memory. Now for diets, Research results show that diets high in omega-3s and DHA may help hippocampal cells communicate better. Now, the hippocampus is where new memories are formed, so it's imperative that the cells can communicate with one another. Contrary to having a healthy diet, exercise helps strengthen memories rather than help the hippocampal cells communicate. Now, on to sleep. Sleep is imperative for forming memories. Recent studies have found that memories that are rehearsed during sleep, as well as during waking, are more likely to be consolidated and therefore better remembered later on. Researchers found that by pairing low value memories with a characteristic sound and then playing that sound to sleeping participants, those low value items were better recalled. Sleep is necessary to rehearse and consolidate the things that we want to remember from our waking day. Learning while sleeping has been a long and unachieved goal of many high school and college students around the globe. It is not learning while sleeping, it is learning something new while sleeping. Participants in one study learned how to play two previously unfamiliar tunes. So just think like a song or two songs that you're unfamiliar with, learn how to play those. Then they took a 90-minute nap, and the researchers, using an EEG, presented one of the tunes they had practiced during slow wave sleep, which is a sleep associated with memory consolidation. So the tune that was presented during sleep was remembered significantly better than the one not presented. And lastly, sleep deprivation interferes with the functioning of the hippocampus, the part of the brain that is vital for new memories. So many high schoolers go through this, or like teenagers in general, but they barely get 7 hours of sleep a night, which is not good for the brain and not good for especially the hippocampus, as stated before, because then you have such a hard time remembering things, and it messes with the functioning of the hippocampus. So that's why getting your sleep each night is imperative for the functioning of your brain and your mental health especially too.